welcome to the Backyard Machine Shop. Today we're back on the Lima drive. We're adapting that 5 horsepower Baldor motor to the Lima drive instead of the 2 horsepower motor, 550 volt motor that was on it. So I've already started. I've got our billet in the machine here, and we've got it roughed out. So now we're starting to do the detail work. So the first thing we plan on doing, and here's the motor housing, is I need to bore a register for the Flange motor for the inner flange. And eventually when I have this done, this is going to be flush mounted with the adapter. So you need to get a good measurement on that. And this is kind of backwards engineering. Alright, our first measurement we need to bore to is going to be 8 inches, 500 and 525 thousandths. So that's our first measurement we need to go to, and we'll check it then. Alright guys, so it's really hot here in the shop today, and right now I have the fans and the phase converter off, so it sounds probably okay. But I'm going to have to run a fan, and I'm going to have to run a phase converter, so we may have to voice over on this tape because the lathe is going to be loud also. So just stay tuned and we'll get this done. Alright guys, so what we're doing here is we're touching our tool off onto the outside face, and we're fixing to rough out the inner flange for the C drive motor. So we're touching off on the face, and then we'll probably come in and touch off on the inner bore. That way we'll know what depth of cut we're going to make. First of all, I got to get it cutting in the right direction, so hang on. Shifting, reversing the feeds. The material we're cutting is 6061 aluminum. It cuts okay. I'd rather have been 2024 or 7050, but 6061 does okay. So basically what we're doing here is we're cutting 1/4 inch deep, and we're going to work this bore out until we get to our diameter of our inner flange on that C flange motor. And the reason I'm cutting the inner one first is I'd rather have it registered good, tighter than the outer one. So I'm just taking my time and getting that inner one corrected. Kind of giving me a reference to where we're starting. I think we had to open this up maybe probably 2 inches in diameter. Chips don't look too good. They don't look too bad, but again, I think we're taking 200 thousandths width on the width, and then 1/4 inch deep. We're boring a little over 1/4 inch actually. All I want to do is give myself some clearance in there where I can fit that register. Alright, that's enough of that. So what we're doing now is we're running about 190 on the RPM, and I'm going to shift it down to 135, and that should make the chips break. Boring something this big, you're constantly having to change your feeds and speeds, and you just have to watch your chip and see what it's doing. Sometimes you can't help it, but most of the time you can get in a range and get it right. And see, the chips are breaking a lot nicer. It's a little slower RPM, a little slower on the cutting, but the feed remain the same. I think I'm feeding around 15 thousandths of rev.
You know, see how the chips are breaking away a little better. All right, we're starting to get close to where our dimension. I like to check a lot. I mean, that's just a habit I have. So getting pretty close. All right, we're starting to fit the flange. I think the biggest thing here is it maybe needed a few tenths and deburring. All right, so that's the flange I just fitted. Now what we need to do is we need to start working on that outside diameter. And basically what I think I done first was I went ahead and bored. That needs to be about 550 deep. And I went ahead and took it down to 550, and then we'll bore the outside diameter. So just retouching off. I want to make sure I go 550 deep. We've set a 0 on that outer flange where we bored it out to. So what we're going to do is we're just going to start it. We're going to go to 550 deep and work ourselves back out to our 0. So we're taking another 250. Cutting this one pretty fast. Now see, now we're changing speeds again. So we're actually slowing down again, trying to get a good chip. I think we're running 95 RPM. Trying to get a little better finish too. Shoot some WD-40 on it. Let's make some smoke. Again, we're stepping over maybe 200 and going to 550 deep. So just about there. Looks like this might be the final pass. Alright guys, so what we have here is we're going to cut this outer flange. Now I had to take this over and turn it on the monarch to get a good round edge. And our main concern though is that we want to go deep enough to where the inner flange is what's actually referencing the part. So we're going to come in, we've got our 0, we know how far we need to go in to cut this, actually how far to come out. And we're going to bore this 1/4 inch deep or 255 deep, and I think we're going to take a total of about a 1/4 inch off. I think the measurement was in 9 inches 625 thousandths if I'm not mistaken. Anyway, like I said, the most important thing is that inside, that register on the inside. Now if you notice, I haven't cleaned that inside surface up yet, so what I'm going to do is during this process is after we bore this, we'll come in and face off all surfaces and get them to where to where it fits like I want it to. And that's to get our register. I think we know where we need to go. And like I said, I had to turn the outside of the piece to make it round. It was not round, so we're going to deburr our part, clean it out. Now it should fit. All right, so we got a good fit. Tap it in tight. I need to check it and make sure it's registering on the bottom surface inside. Tap it until you can feel it seat. I can look through the chuck and see where that bottom surface is registering, and it looks good. Got, ain't quite flush, maybe 10 thousandths deep, which I think I'm gonna leave it just like it is. You can see we got a good fit in there. By the time I clean everything up, it'll be a little bit lighter. So now what we're going to do is we're going to turn our outer dimension, our outside diameter down to the same diameter of the drive. Making these light cuts, you see the little strings coming off. So now we're starting to make some good cuts. We got our measurements, know where we're at. I think we're taking maybe a 1/4 inch off the side, or sorry, a 1/4 inch off, 125 thousandths a side. Let's speed it back up to 135. Probably should have left it where it was at 95, but now we're throwing chips everywhere, and they're not, and they're hot. You'll see me get hit by one every now and then. So just trying to get it turned down. Again, we're using WD-40. All right. Dialing in for our final pass. Slowing the speed down just a little bit. Or actually, I think we sped it up some. Slowed it down, trying to get a finish cut is what it was. All right, that's pretty much it. Measure it up, taking chamfer all the edges, and flip it around and do the other side. Alright guys, so what we have here, we flipped the part around, indicated it back in, and now we're facing off all the meat that was on the back side. We'll face it all the way down to an inch and a half, which is our dimension. So we're taking maybe, I think, a 200 thousandths cut. And just, it's that simple, just facing off. Got a lot of chips. I've had a lot of chips in this video, or in this part. I don't know about your lathes, but this lathe's got a drop chute there that just will not take many chips, and it plugs up real quick. You're constantly having to clean it out. Again, WD-40. I'm just mowing it down. So what we're looking at here is we're looking at the opposite side. This is actually the side that will go up against the drive. So I'm using the bell housing off the old motor, the end cap, to fit this one. We're going to have to machine this outer lip. That's where the fit's going to be. So we're going to use the bell housing as a test fixture for the adapter. So what I'm saying here is we got to take and cut. We're going to cut 70 thousandths deep, and or maybe it's 100 thousandths deep, and machine all the way out to that outer edge. Now, instead of using a boring bar here, I'm actually using a lathe tool, insert tool, which cuts better. It breaks the chip better, and you can feed out with it. The problem is there's not enough clearance at the bottom, so you can only take about 70 or 80 thousandths cut. So I think that's what I'm limited to, is maybe I'm doing like 50 thousandths at a time, but it's still a lot faster than plunging a boring bar in there. The problem with the boring bars, I could not find one, or could not find feeds and speeds to where I could make one chip. So this turned out better. So we're taking the 50,000 and taking a second 50. We're just working it out to the outer flange there, and once we get it out there, we'll adjust the flange to fit. This is what's good about doing parts for yourself, and parts when you got all the pieces there that you can fit up, and you can just take your time and make them fit the fit you want anyway. Most of the parts we build at work, we never see the finished part, so we don't know how they fit. We just build them to dimensions. There goes the little bird nest again. Cutting them light cuts, you just can't make a chip. Deburr the edge a little bit. Still need a couple of tenths off of it. I don't know what you guys, but that looks like a pig to me. Maybe one of those pigs off of that game Angry Birds or something. So yeah, we got a nice fit. And like I said, doing it at home and having the time to do all that and all the parts, you can get good fits like that. So,
All right, guys, here we have it. We have the drive side and motor side. So we're going to stick it together, see what it looks like. Stay tuned. All right, so you didn't get to see this on the camera. I don't think so anyway. I haven't looked at the video yet, but all my batteries died and all my cameras, so luckily we're getting this done. Well, anyway, this fits this motor plate here. And, it'll go right on. Alright, so you got a good, nice, snug fit right there. Let's turn it where you can see it. Okay, so let's put this motor in next. So again, you got the two registers on the motor, and they go in. They're a good fit. A little heavy on the back side there. Alright, so we're going to rotate them. Now we need to slide this motor on. There you have it. I think it looks pretty good. I got a few things I got to do. One, we got to drill the mounting holes, which won't be a problem. And I'm not sure, but I planned on putting a slight radius on this edge right here, but I think it looks good just like it is. And it looks like that we're going to have to cut the shaft just a little bit more to get it to fit. Turns good. I mean, the gearbox ain't together, but it's going through to the bearing. There's no binding in the motor. Yeah, see what it looks like. That's what it'll look like in the end. I'm pleased with it. It's a lot of work. I got a lot of chips here in the shop. I got to get cleaned up. Probably take me 2 days to clean them up. So, I want to thank everybody for watching. I want to thank all my subscribers, all my new subscribers, all my old subscribers, everybody that comments and hits the like button. I even thank the people that hit the dislike button. At least they're watching. So, we're about through this. Well, we're a long ways to go in this project, but at least we got to see what it's going to look like. And you know, we got to put the gearbox back together. We got to do a few other things, and we'll have this one together. So, again, like I said, all my subscribers, everyone that watches, everybody hits the like button. Thank you. And from the Backyard Machine Shop, so long.